which depends on the number of solute particles only. Example for these colligative properties that we have studied was, one is said to be elevation. First one what we have studied is RLVP, relative lowering of vapor pressure. This was the first example. Second example that we have studied was elevation in boiling point, so we have written it as delta TB. Third one that we have studied was depression in freezing point, that was delta TF. And the fourth colligative property that we have studied yesterday was osmotic pressure. So the symbolic notation that we have given for osmotic pressure is pi. So this is called as osmotic pressure. Now you have studied the formula for RLVP. The formula for RLVP is P1 naught minus P1 divided by P1 naught, that is equal to W2 into M1 divided by W2 into M1 divided by M2 into W1, M2 into W1. This was the formula that we have studied in our yesterday and day before yesterday class. Delta TB, we have studied delta TB, that is equal to KB into W2 into 1000 divided by M2 into W1. And also we have studied another formula, delta TB is equal to TB minus TB naught, where TB naught is the boiling point of the pure solvent and TB is the boiling point of the solution. We have studied delta TF formula. Delta TF is equal to, I'll write it little bit now, delta TF, this is equal to KF multiplied by W2 multiplied by 1000 divided by M2 into W1, and also you have studied delta TF, this is equal to TF naught minus TF. So this many things you have studied in your previous class, and also yesterday we have studied something about osmotic pressure. So just I'll start with the introduction of that osmotic pressure again. Yesterday I have studied about in detail about that osmotic pressure. We have derived some equations also. So now let me write. We have studied the concept of osmosis. What is osmosis? Flow of solvent molecules from a region of low concentration solution to high concentration solution. It is important to know that we are telling that flow of solvent molecules from a region of low concentration solution to high concentration solution through semi permeable membrane. We have discussed the examples of osmosis yesterday. Now example for semi permeable membrane, you know that semi permeable membrane can be naturally occurring, maybe animal membranes or plant membrane, plant membranes, or it can be synthetic. Yesterday I told you, for synthetic example can be asked in the examination. For synthetic example can be asked in the examination. So example is cellophane. And you should know that these semi permeable membranes have a network of submicroscopic holes or pores, small, which allows only small molecules to pass. Solvent molecules are generally small, and hence only the solvent molecules would pass through it. So these are the things that we have studied. Then after studying this, we have studied a concept called as what is osmotic pressure. What is osmotic pressure? What is osmotic pressure? What is osmotic pressure, which is denoted as pi. We know that yesterday we have studied, if we have two compartments separated by semi-permeable membrane, let us say this is said to be semi-permeable membrane. Here let us say you have a solution. Let us say here you have a solution. This is solution, and on to the other side what we have is the pure solvent. Let us say what you have here is the pure solvent. Pure solvent. Definitely vapor pressure above the surface of the solvent would be more. Vapor pressure of this solvent above this solvent would be more, and vapor pressure here would be less. Due to the difference in the vapor pressure above these solutions, it exerts more of pressure on this, and hence the solvent molecules start moving through this semi-permeable membrane, and we call this concept as osmosis. See, what is the reason for osmosis? The difference in the vapor pressure. So now if I take a piston and if I start applying high pressure, if I start applying the high pressure above the solution side, I am applying an extra pressure. Let me say that extra pressure, I'll call it as pi, which will equalize the vapor pressure on two sides. Then the flow of this solvent molecules from the solvent side to the solution side can be stopped. So what extra pressure that we have to apply on the solution side so as to prevent the process of osmosis, that is called as osmotic pressure. So even this concept also we have studied. So what is that osmotic pressure? The extra pressure that has to be applied, the extra pressure that has to be applied, that has to be applied on solution side, on solution side to just prevent the process of osmosis is known as osmotic pressure. Important for 1 mark. Is known as osmotic pressure. I think students, this point is clear to you. Now even this part was discussed yesterday. Let me go for the next part. Now we should know that, suppose say that pi is the osmotic pressure. Suppose say that pi is the osmotic pressure of a solution. That should be directly proportional to concentration of the solution, because higher the concentration, more is the solute particles in the solution, more is the blocking of the surface, vapor pressure would be very less. So therefore you have to apply high pressure. Pi is directly proportional to the concentration of the solution in molarity. Pi is also directly proportional to temperature. Definitely you know that pi is always directly proportional to pressure. So combining this, we can say that pi is directly proportional to C into T. So implies pi will be equal to some constant R into C into T. I told you, how can you remember this easily? Pi is equal to cathode ray tube. It is not cathode ray tube, it is just a shortcut to remember. Now tell me, what is C? C is said to be concentration in molarity. C is said to be concentration in molarity. R is said to be universal gas constant. Universal gas constant. Universal gas constant. T is said to be temperature in Kelvin. T is said to be temperature in Kelvin. T is said to be temperature in Kelvin. Now we can do some modifications for this formula. You know that what is C? C, molar concentration, that is nothing but number of moles of solute divided by volume of the solution in liters. Volume of the solution in liters. If W2 grams of solute of molar mass M2 is dissolved in V volume of the solution, then we can write concentration of the solution will be equal to number of moles can be written as W2 divided by M2 into volume of the solution in liter, that is V. So substituting, incorporating this in the equation of pi will be equal to, wherever C is there, we'll write as W2 by M2 into V, where V is the volume of the solution in liter, into RT. So what is the formula for pi? So pi will be equal to W2 into RT divided by M2 into V. Students, I told you yesterday that you have to remember this formula. So now it is very clearly understood that pi is always more when concentration is more. So therefore, always remember this point. So osmotic pressure of a solution is always more for a high concentration solution. Osmotic pressure of a solution is high when concentration of the solution is high. When concentration of the solution is high. So you need to remember this point. Pi is directly proportional to C. Okay. Moving on further. So I told you that you have to remember this formula. What is this formula? Pi is equal to W2 into RT divided by M2 into V, where V is the volume of the solution in liter. The value of R depends upon what is the unit of pi. Now, students, we shall study the next part. Suppose say that you have two compartments which is separated by a semi-permeable membrane. Let me call this as SPM. The two sides of this compartments are filled with, let me say this is solution 1, this is solution 1, this is said to be solution 2. I am not mentioning anything about concentration. Now directly I will ask you, suppose if the osmotic pressure of this solution is written as pi 1, suppose if the osmotic pressure of this solution is written as pi 2, if it is written as pi 2, what does pi stands for? Osmotic pressure. And if I say that pi 2 is greater than pi 1, pi 2 is greater than pi 1. Now I'll ask you, solution or solvent molecules will move from which compartment to which compartment? Which compartment to where? From which compartment to which compartment? Which compartment to which compartment? Which compartment? Okay, now I think you got what is my question. I'm asking if this is compartment 1, and if this is compartment 2, and if the osmotic pressure of 2 is greater than the osmotic pressure 1, the direction of flow of solvent molecules will be in which direction? Will it be from compartment 1 to compartment 2, or will it be from compartment 2 to compartment 1? Think on it. Okay, now listen students, what is given? Pi 2 is greater than pi 1. If the osmotic pressure is more, if the osmotic pressure is more, concentration of the solution also should be more. Pi is directly proportional to C. That is what we have studied. If pi is directly proportional to C, then if I tell the concentration is C2 in this compartment and concentration is C1 in this compartment, definitely you can understand concentration 2 is more than concentration 1. Always you know that during osmosis, the movement of solvent molecules will be from a region of low concentration solution to the high concentration solution. So since C1 is low concentration than C1, so this is low concentration, the movement of solvent molecules will be from a region of low concentration to high concentration. So the solvent molecules will move in this direction. It will be moving from compartment 1 to compartment 2. It will be moving from compartment 1 to compartment 2. I think students you got this point. This kind of tricky questions can also be asked. Okay, now moving on to the next topic. Let us study something called as tonicity of a solution. Let us study something called as tonicity. Actually, this is a generic word which is used by the chemistry teachers. There is no word tonicity used in your NCERT book. So let me make it very clear. Let's say that based on tonicity of the solution, there are three types. Tonicity of a solution. Tonicity of the solution. Based on osmotic pressure of the other solution, the given solution can be of three types. So the first type is called as isotonic solution. Isotonic solution. The second category is called as hypertonic solution. Hypertonic solution. And the third category is called as hypotonic solution. Hypotonic solution. So based on the tonicity, so we have three types of solution. So isotonic, hypertonic, hypotonic. Tell me, iso means what? Same. Iso means same. Hyper means more. What is the meaning of hypo? Less. Less. What? Same osmotic pressure. Hyper means more osmotic pressure than the other solution. Less. Hypotonic means what? Less osmotic pressure than the other solution. So what is isotonic solution? Two solutions having same osmotic pressure. What is hypertonic solution? If a solution has more osmotic pressure than the other, then we call it as hypertonic solution. What do you mean by hypotonic solution? If a solution has less osmotic pressure than the other solution, then we call it as hypotonic solution. Now, just an example which is mentioned in your NCERT, many times it is asked in the examination, so which is very important. Now say that first we'll discuss something about isotonic solution. What are isotonic solutions? These are the solutions which have same osmotic pressure. These are the solutions which have same osmotic pressure, or if two solutions have same osmotic pressure, then we call it as isotonic solution. As an example, that you should know that osmotic pressure associated with blood fluids, osmotic pressure associated with blood fluids, pi of blood fluids, pi of blood fluids, pi of blood fluids. Osmotic pressure associated with blood fluids is equivalent to, is equal or equivalent to, is equal to 0.9%, 0.9% mass by volume, 0.9% mass by volume sodium chloride solution, sodium chloride solution, NaCl. Cl solution, sodium chloride solution. This is a fact that you need to remember. Osmotic pressure of blood fluid is equal to 0.9% mass by volume of NaCl. It means that if the concentration of NaCl solution is 0.9% mass by volume, then such an aqueous normal saline solution would be isotonic with respect to the blood fluid solutions. Now, based on this, let me ask you a question now. Suppose say that if a blood cell if a blood cell is placed in a solution containing 0.9% in a solution containing more than 0.9% mass by volume, sodium chloride. Full stop. What will happen to blood cell? What will happen to blood cell? Think on it. What will happen to blood cell? Think on this, students. What is given? A blood cell. Let us say this is a blood cell. Which is placed in a solution. Let me say this is a container. Where you have aqueous NaCl. This is aqueous NaCl whose concentration is more than 0.9% mass by volume, whose concentration is greater than 0.9% m by v. Definitely you know that if the concentration of the outer solution is more, so what should happen to the liquid which is present inside? So as to dilute the outer solution, liquid has to come out, water molecules has to move out. So if the water molecule is moving out, so what should happen to the size of the blood cell? Whether it will swell or shrink. So size of the blood cell decreases, so we can call it as it shrinks. What will happen? It shrinks. So what is the answer for the given question? It shrinks. SHRINKS. Now tell me, students, which solution would be having higher osmotic pressure? Aqueous NaCl. So therefore this term is called as this kind of solution is called as hypertonic solution. I think this point is clear to you, students. When a blood cell is placed in a solution containing more than 0.9% mass by volume NaCl, what happens to the blood cell? If the concentration of the outside solution is more, it has to be diluted, so water moves out from the blood cell. So what will happen to the size of the blood cell? It decreases. We can call it as it shrinks. So what would be the osmotic pressure of the solution, aqueous NaCl solution? It would be more. So we call aqueous NaCl is hypertonic with respect to the blood cell. I think this point is clear. It was asked in the annual examination. So this is an important question, students, for 1 mark. You know that in solution chapters. So question number 1 and 2 in the annual examination will be from this chapter. This kind of questions can be asked. Let me say that on the other hand, if we place a blood cell in a solution containing less, now I'm changing it as less than 0.9% mass by volume solution, what will happen to the blood cell? What will happen to the blood cell? Now this is the question. What will happen to the blood cell? Think on it. What should happen to the size of the blood cell? So let me erase this. Now let us think. If we place a blood cell, let me call this as a blood cell, in a solution whose concentration is less than 0.9% mass by volume, 0.9% mass by volume. This is aqueous NaCl whose concentration is less than 0.9% m by v, 0.9% m by v. What would happen to the blood cell? Now you know that outside concentration is less. If the outside concentration is less, water should move from outside to the high concentration region. Water enters inside, so water will enter inside the cell. What is the meaning of that? So it is nothing but called as water is entering, so it should swell. It should swell. Size has to increase. Now the solution is termed to be, aqueous NaCl solution is termed to be what? It is called as hypotonic solution. Hypotonic because its osmotic pressure is less when compared to the osmotic pressure of blood cell. So what do we call this as? This is called as hypotonic solution. So students, we have studied all three categories based on the tonicity of the solution. So what are the three kinds of things? One is said to be hypertonic, another one is said to be hypotonic, and the last kind is said to be isotonic solution. So we have studied all these things. Definition can be asked, and the last example what I told about the blood cell is important. So what did I tell? You should remember that blood cell fluids are isotonic with 0.9% m by v aqueous NaCl. This is a fact that you need to remember now. So based on this, question can be asked whether the cell will shrink or whether it will swell. Such kind of questions can be asked. Another important name is mentioned in your NCERT. So that is called as edema. What is edema can be asked for 1 mark. What is edema? Edema means what? People taking lot of salt or salty food experiences. People taking lot of salt consumption is more, means retention of water in tissue cells or intercellular spaces occurs because of osmosis. This resulting condition or puffiness, because of retention of water, resulting puffiness or swelling, is called edema. This also can be asked for 1 mark. People who consume lot of salt or salty food, because of the osmosis, water gets trapped in between the intercellular spaces or tissues, and this will result in the puffiness or swelling. This will result in the puffiness or swelling, and this condition is called as what? Edema. I think students, this point is clear to you. Next, we said that just to prevent the process of osmosis, we need to apply an external pressure on the solution side. Now say that we have a container which is divided into two compartments using semi-permeable membrane. Let me say this is said to be SPM, semi-permeable membrane. Now let me say that I am drawing the setup. This is also important for 2 marks. Let me say that onto one side, so we have salt water, we have salt water, we can call it as solution. On to the other side, let me say we have pure water, we shall say we have pure water, let me draw it here as pure water. This is pure water. Let me call it as pure water. Now on the solution side, let me say that here we have a setup so that we can apply high pressure. This is piston, this is said to be 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 a piston. I am going to apply an higher pressure here. Pressure applied is greater than pi. If it is equal to pi, then the process of osmosis stops. Now if I am going to apply a higher pressure than that of the osmotic pressure, definitely vapor pressure on the solution side increases and the movement of solvent molecules will be from this side to this side. Water molecules will start moving into the pure solvent side. If the applied pressure is equal to pi, osmosis stops. If the applied pressure is greater than osmotic pressure, then the movement of solvent molecules from the solution side to the solvent side takes place, and we term this as reverse osmosis. What do we call this as? Reverse osmosis. You might have seen in many of the water purifiers RO. What does that mean? RO means reverse osmosis, and we term this process as desalination of seawater. What do we call it as? Desalination of seawater or salt water. So it is a method of purification of water. So this can be asked for 2 marks, students. So explain an application of reverse osmosis. An application of reverse osmosis is desalination of seawater. Explain desalination of water can also be asked. Draw this diagram. So when you apply the extra pressure, you can say that here pure water comes out. Pure water will be dripping out. That is because of the movement of solvent molecules from the solution side to the solvent side. I think this point is clear, students. So give an application of reverse osmosis, desalination of seawater. Just draw this diagram. Then say that an external pressure is applied on the solution side higher than that of the osmotic pressure. Pure water starts moving from salt solution side, salt water side to the pure water side, and hence water gets purified. So this is termed as desalination of seawater. I think this point is clear to you, students. What is the definition of reverse osmosis? By the application of an external pressure higher than the osmotic pressure on the solution side, solvent molecule starts moving from solution side to the solvent side. This is termed as reverse osmosis. So the definitions are given in your study material. So you need to, by heart it students, you need to know in page number 92. So if they have given the definition of reverse osmosis, if an external pressure is applied on the solution such that the applied pressure is greater than the osmotic pressure of the solution, the solvent molecules moves from the solution to the solvent. This phenomenon is called as reverse osmosis. And as an example for the application of reverse osmosis, desalination of seawater is given. So just refer your NCERT for the diagram and write the statements what I told you now. I think this point is clear to you students. Now let us look into some problems. Let us solve some problems based on this. So this is the first question that we need to solve. Let's read the question. Calculate the osmotic pressure. So they are asking you have to calculate pi. Pi is a question mark. Prepared by dissolving 1.8 gram of glucose. So we know what is W2. 1.8 gram in 1 liter of solution. So volume of the solution is said to be 1 liter. At 300 Kelvin, so temperature is given as 300 Kelvin. Temperature is equal to 300 Kelvin. Molar mass of glucose is given. Molar mass of glucose is given. M2 is equal to 180 gram per mole. 180 gram per mole. And R value is given in the problem 0.083 bar liter per Kelvin per mole. That is given in the question itself. So you have to calculate pi. Students, tell me what is the formula. Yesterday itself I told you that you need to by heart the formula. So pi is equal to W2 into RT divided by M2 into V. This is the formula that you need to learn. If you know the formula, now you can substitute all the things. This should be equal to W2 is known as 1.8 multiplied by R value is known. It is given in the problem 0.083 multiplied by temperature is given as 300 Kelvin. Temperature is given as 300 Kelvin divided by M2 is given as 180 multiplied by volume of the solution is given as 1 liter. So now you can work out on this. So take your calculator and start working, students. Tell me what is the answer. Students, the answer will be coming out as 0.249 bar. 0.249 bar. I think this is clear, students. Shall we go for the next question? Just note down the solution, then we'll go for the next question. You don't have to write the problem because it is there in your study material. Question number 17 is given in page number 92. Okay. Shall we go for the next question, students? Question number 18. Question number 18. It is given in your study material in page number 92. So let us start solving the problems. Given temperature is 298. Temperature is 298. You can see it here. Osmotic pressure pi is given. Pi is equal to 2.4 atm. 2.4 atm is given. 5.5 gram of solute, so that is W2, 5.5 grams solute. In 200 ml of solution, V is given as 200 ml. that should be equal to 0.2 liters. R value is given in the question. R is equal to 0.082 liter atm per Kelvin per mole. We need to calculate the molar mass of the solute. So M2 is the asked question. M2 is equal to question mark. Okay, now students, how to solve this question? You know that pi is equal to W2 into RT divided by M2 into V. So implies M2 will be equal to W2 into RT divided by pi into V. So substituting the value, W2 is 5.5 grams, 5.5 gram into R value is given 0.082 multiplied by temperature is given as 298 divided by pi value is given as 2.4 atm multiplied by volume of the solution should be in liters, that is 0.2. So take your calculator and work, students. Tell me what is the molar mass. So what is the answer, students? Answer comes out as 279.996 gram per mole. Gram per mole. Is it clear? Just copy down the solution, students. Okay, shall we go for the next question, students? Question number 20. See, I'm skipping question number 19. I'll solve it after the next part. So now we'll go for question number 20. I'll solve question number 19 after the next topic. The osmotic pressure of a 3% solution of the compound is at 300 Kelvin is 4.8 into 10 to the power. So they have given osmotic pressure pi is equal to 4.8 into 10 to the power of 5 Pascal. It is given as Pascal. It is in the SI unit. Temperature is given as 300 Kelvin. Temperature is equal to 300 Kelvin. They have given solution is 3%. Solution is 3%, implies 3 gram of solute. 3 gram of solute is present in 100 ml of solution. 100 ml of solution. That is the meaning of 3%. Now we may ask, how can we understand it is 3% mass by volume? Generally, so we are studying about the dissolution of a non-volatile solute in a volatile solvent. Definitely, so percentage in this case should be mass by volume percentage. So which implies they have given W2 is equal to 3 grams. W2 is equal to 3 grams. They are asking you what is M2. M2 is a question mark. Now let us go for this. Pi is equal to W2 into RT divided by M2 into V. Now let us keep on substituting all these things, whatever is given there. So let us write here as 4.8 into 10 to the power of 5 Pascal. That is equal to W2 is given as 3 gram multiplied by, so now we have to write the value of R in terms of SI unit. R will be equal to 8.314 joule per Kelvin per mole. Joule per Kelvin per mole. So this is 8.314 multiplied by temperature is given as 300 Kelvin divided by molar mass is given. So molar mass of the solute has to be calculated. I'll write as M2 multiplied by volume of the solution is given as 100 ml of solution. It is nothing but 0.1 liter. This is equal to 0.1 liters. So 0.1 liter should be expressed in terms of meter cube. 1 liter is equal to 10 power minus 3 meter cube. This will be equal to 10 to the power minus 3 meter cube per liter. Meter cube per liter. So therefore I have to write it as 0.1 liter into 10 to the power minus 3 meter cube. I think all of you got it, students. Now you have to calculate the value of M2. M2 will be equal to, so 3 into 8.314 multiplied by 300 divided by 4.8 into 10 to the power of 5. 4.8 into 10 to the power of 5 multiplied by 0.1 into 10 to the power of minus 3. 10 to the power of minus 3. Take your calculator and start solving, students. You'll get the answer. So this will be equal to 155.8875 unit should be gram per mole for the molar mass. Gram per mole. 155.8875 gram per mole. I think this point is clear to you, students. So if you want to go by dimensional analysis for the unit of this, so let us write M2 will be equal to, so the unit what we have substituted, will write this is in terms of grams multiplied by, so 8.314 will be having the unit as Pascal meter cube. We can write it in terms of Pascal meter cube. Pascal meter cube per Kelvin per mole, per Kelvin per mole, multiplied by 300 is in terms of Kelvin, divided by, this is given in terms of Pascal, this is given in terms of Pascal, multiplied by unit of volume is meter cube. Unit of volume is meter cube. Now students, let us see what are the units that are going to be cancelled and what is remaining. Pascal, Pascal, meter cube, meter cube. So here it is Kelvin and per Kelvin, it gets cancelled. So the unit remaining is gram per mole. So the unit of M2 what you're getting in the numerical should be gram per mole. It should be in terms of gram per mole. I think it's clear, students. Just note down. Okay, let us start solving the next question, students. What is given here? Let us read the next question. Question number 21. Question number 21. 5% urea solution is isotonic with a solution containing 30 grams in 200 cm cube of the solution. If the molar mass of urea is 60 gram per mole, calculate that of glucose. Okay, now what is the meaning of 5% solution? Just now we have written, let us write it for two things. Urea is one thing, glucose is another thing. And now we know that 5% means mass of solute that is dissolved in 100 ml is 5 grams. Volume of the solution will be equal to 100 ml. It is 5% M by V solution is nothing but 5 gram is dissolved in suitable solvent, so that the final volume of the solution is said to be 100 ml. And weight of glucose is given, W2 is equal to 30 grams. It is given here 30 grams. and volume of the solution is given as 200 cm cube, that is nothing but 200 ml. And they said that if the molar mass of urea M2 is said to be 60 gram per mole, 60 gram per mole, what would be the molar mass of glucose? You know the answer, what is the molar mass of glucose, but we need to show it mathematically here. What would be the answer? Now, we know there is a formula, pi is equal to W2 into RT divided by M2 into V. If two solutions, they said that is isotonic. What do you mean by isotonic solutions? So pi of urea is equal to pi of glucose. This is what given in the problem. Now I can write two equations like this. Pi of urea is equal to W2 into RT by M2V of urea, and pi of glucose is equal to W2 into RT divided by M2 of V. Then we have to equate the two equations. Now what we get, W2 into, I don't have to write, I'll write it RT divided by M2 into V of urea, that should be equal to W2 into RT by M2 into V of glucose. I think students this is clear to you. Now you know that since temperature is not mentioned, we should take it as same. This RT cancels. So if it is cancelling on two sides, then we can write W2 by M2 into V. Volume is not same because this is 100 ml, this is 200 ml of urea. That should be equal to W2 by M2 into V of glucose. Now we can calculate what is M2 substituting all the values. W2 is given. What is W2 value for urea? 5 divided by M2 is given as 60 multiplied by volume is given as 100 ml. That should be equal to W2 is given here as 30 divided by M2 has to be calculated for glucose multiplied by volume is given as 200 ml. So definitely you can understand, students, this is 1 times here, this is 2 times, and this is said to be, now implies M2 will be equal to 30 into 60 divided by 5 into 2. 5 ones are 5 6 are 2 ones are 2 3s are. So this is coming out as 180 gram per mole. 180 gram per mole. So answer for the given question is 180 gram per mole. Just look into the solution, students. After completing here, we came here. Let us look into the next question, students. This is an NCERT example 2.11. $200 cm cube. So volume is given as 200 cm cube. That is equal to 200 ml. That is equal to 0.2 liters of an aqueous solution of protein containing 1.26 gram of protein. So W2 is given as 1.26 gram. The osmotic pressure pi of such a solution, pi is given, pi is equal to 2.57 into 10 to the power of minus 3 bar into 10 to the power of minus 3 bar. I think this is clear to you, students. Then they are asking, this is done. Calculate the molar mass of the solute. M2 is a question mark. Temperature is given you can see here it is given as 300 Kelvin. 300 Kelvin. So you have to calculate the molar mass of the solute. Okay. Now we know pi is equal to W2 RT by M2 into V. We need the value of R. R value can be substituted. See, you can see the unit as bar and you can see this unit as liter. So I should write as 0.083 bar liter per Kelvin per mole. Bar liter per Kelvin per mole. Now we need to calculate M2. Altering this formula implies M2 will be equal to W2 RT by pi into V. Pi into V. So implies M2 will be equal to W2 is known 1.26 multiplied by R value, it is 0.083 multiplied by temperature in Kelvin, that is 300 Kelvin, divided by pi value is given. Pi value is coming out to be 2.57 into 10 to the power minus 3 bar multiplied by 0.2. Solve the problem and tell me what is the answer, students. Implies you can use the calculator and tell me what is the value of M2. M2 will be equal to M2 comes out to be 61,038.91 gram per mole. Important, students. These kind of questions can be asked for 3 marks. Shall we go for the next problem, students? Just have a look on the next problem. This is an in-text question. So 2.12, you don't have to write the question, students. So I have written in-text 2.12. Just refer that for the question. Note down the question number and then you can solve it. It is given in page number 57, in-text 2.12 question. Okay, let's see, students, what is given. Calculate the osmotic pressure in pascals. So pi has to be calculated. Pi is equal to dash pascals. This is what we need to determine. By a solution prepared by dissolving 1.0 gram of polymer, W2 is equal to 1.0 grams of a polymer of molar mass, M2 is given as 1,85,000 gram per mole. You should know the unit of the molar mass is gram per mole. Volume of the solution is given as 450 ml. So that is equal to 450 multiplied by 10 to the power of minus 3 multiplied by 10 to the power of minus 3 meter cube. Temperature is given as 37 degrees Celsius. That is equal to 37 plus 273.15 Kelvin, that is coming out to be 310.15 Kelvin. Is it clear, students? Now, since the pi should come out in the SI unit, R should be equal to 8.314 joule per Kelvin per mole. Joule per Kelvin per mole. You need to calculate the osmotic pressure. You know what is the formula that has to be used. Pi is equal to W2 into RT divided by M2 into V. So pi will be equal to W2 is 1.0 multiplied by 8.314 multiplied by temperature is known, that is said to be 310.15 Kelvin, divided by M2 1,85,000, multiplied by volume is 450 into 10 to the power of minus 6. 450 into 10 to the power of minus 6. 10 to the power minus 3 into 10 power minus 3 is 10 to the power of minus 6. So substitute all these values, take the calculator, solve this, students, you will get the answer. So it is very simple. You can also write this as 1, 2, 3, 4, 5. So you can write this 1.85 into 10 to the power of 5, so that the calculation becomes much easier. Now calculate and tell me what is the answer, students. What will be the value of osmotic pressure? That comes out to be 30.97 pascals. 30.97 pascals. I think this is clear. So that is all about the problems that we have studied, students. Now we have to study a small concept. We are at the end of the chapter now, so we are at the end that we need to study something called as abnormal molar mass. We need to study a concept called as abnormal molar mass. Abnormal molar mass. Abnormal molar mass. Abnormal molar mass. Let's see what is this abnormal. It is obvious that you can understand which is not a correct molar mass. See, students, under colligative properties we have studied that. What is a colligative property? Tell me, what is a colligative property? Colligative property means that these are the properties of the solution which depends only on number of solute particles. Number of solute particles. Irrespective of their nature, whatever might be the nature, it will not depend on the nature. It depends only on what? Number of solute particles. Now, if it is depending only on the number of solute particles, now let me say that I am taking the solute as NaCl. This NaCl solid is added into water. It is added to water. Now tell me, students, what will happen? Since NaCl is an electrolyte, it is a strong electrolyte, it dissociates to give you Na plus aqueous plus Cl minus aqueous. Plus Cl minus aqueous. Do you agree with this? Since NaCl is an electrolyte, it would dissociate to give you Na plus and Cl minus. If I take NaCl as one particle, when I add it to water, it will dissociate to give you one Na plus and one Cl minus. So now for all our calculations, what we have taken, and that W2 by M2 was common in all the expressions of colligative properties. Do you agree with that? Means if I have taken 58.5 grams of NaCl, so we have divided by 58.5 and it would become 1 mole. But you have to remember that if I take one particle of NaCl, after dissolution it becomes 2 particles. If I take 1 mole of NaCl, it becomes 2 moles of NaCl. But for our calculation, what we took? W2 by M2. So W2 by M2 is nothing but the number of moles. So we have considered the moles of NaCl. Now here the number of moles of particles in the solution is double than what we have taken. So therefore, whatever the molar mass we have calculated using all those formulas, maybe delta TB or delta TF or maybe pi or maybe relative lowering of vapor pressure, that would not give you a correct molar mass because of this discrepancy. And hence we call such kind of molar mass what we have determined experimentally as abnormal molar mass. Abnormal molar mass. I think, students, all of you got it. Why it is abnormal molar mass? Colligative property. What is it? it depends on number of solute particles. These are the properties of the solution which depends only on number of solute particles, which do not depend on its nature. For all our calculation, what we took everywhere in the colligative properties formula, we had W2 by M2. It is nothing but the number of moles of solute what we have taken. But there can be certain substances which will dissociate, or it may also associate. The example what I have taken is nothing but called as what, which is going to dissociate. So based on the number of solute particles what we have taken, without considering this dissociation or without considering certain examples for association, we would calculate the molar mass. And hence, if you calculate theoretically by writing those formulas, you would get a wrong molar mass, and hence we call that as a abnormal molar mass. I think students, it is clear to you. Now, in order to correct it, we need to include another factor which is known as Van't Hoff factor, Now let me say, students, abnormal molar mass concept is over. Now, to get the correct molar mass, then we need to include a factor which is called as Van't Hoff factor. The symbol that is given for Van't Hoff factor is small letter I, Van't Hoff factor. Why do we use this word Van't Hoff factor? Whatever molar mass we got from the colligative property calculation would not be correct, and we would call it as abnormal molar mass. To get the correct molar mass, then we need to include a factor which is called as what? Van't Hoff factor. Now let me define what is that Van't Hoff factor. This Van't Hoff factor can be defined in different ways. I can write it as Van't Hoff factor is nothing but equal to the ratio of normal molar mass of solute divided by abnormal molar mass. How do you get the abnormal molar mass? Experimentally, abnormal molar mass. You need to remember this. What is Van't Hoff factor I? Normal molar mass divided by abnormal molar mass. How do you get this normal molar mass? Suppose say that I have something like NaCl. What is the molar mass of NaCl? Add the atomic masses, it is coming out as 58.5 gram per mole. So this is called as normal molar mass. Whatever you get by the experiments, so that we have already seen delta TB, delta TF, or maybe RLVP, or it may be pi. From that, whatever you get, this is called as what? Abnormal molar mass. This is called as normal molar mass. Abnormal molar mass will come out from the values of colligative properties delta TF or delta TB, or it may be RLVP. So based on this, whatever you calculate, that molar mass is called as what? That is called as abnormal molar mass. I told you that it can be defined in other ways also. The Van't Hoff factor I can also be determined as observed colligative property, observed colligative property means through experiment divided by calculated colligative property. This is another definition for colligative Van't Hoff factor. And the third, another definition for colligative property can be total number of moles of particles after association. I'll write as AS, okay, association, or dissociation, I'll write DISS, divided by total number of moles of particles before association or dissociation. So these are the three important formulas that you need to remember. So what is I? I is called as Van't Hoff factor. that can be determined as I is equal to normal molar mass of the solute divided by abnormal molar mass of the solute. Abnormal molar mass is calculated using delta TF, delta TB or RLVP. I is equal to observed colligative property divided by calculated colligative property. Or I can be calculated as total number of moles of particles after association or dissociation divided by total number of moles of particles before association or dissociation. I think these points are clear to you, students. Now, you have to include this Van't Hoff factor I for getting the proper molar masses. So therefore, including this Van't Hoff factor, so let me write all the colligative properties formulas. So I have to write it as delta. First we'll write it for RLVP, P1 naught minus P1 divided by P1 naught, that is equal to W2 into M1 divided by M2 into W1 multiplied by the Van't Hoff factor, so that using this equation, if you calculate M2, you'll get the correct normal molar mass. The second formula that we need to study is delta TF, delta TB we have studied, we'll write delta TB, that is equal to KB multiplied by molality multiplied by I. Molality can be further expanded. Delta TF is equal to KF into M into I. Van't Hoff factor has to be included. Pi, this is equal to, so I can write as concentration of the solution in molarity into RT multiplied by I. So if I include this Van't Hoff factor, so if I calculate the molar mass, so I can write this in the expanded forms also. M can be substituted. I can write this as KB multiplied by W2 into 1000 divided by M2 into W1 into I. Here I can write this as KF into W2 into 1000 divided by M2 into W1 multiplied by I. This will be equal to W2 RT by M2 into V into I. So these are the important formulas, including Van't Hoff factor. Whenever you have an electrolyte, you need to use this. Now, certain important things that you have to remember here is that, as we said, there can be dissociation, there can be association also. If I take acetic acid, I can take this in benzene, I can take it in benzene, then two molecules of this would associate so as to form one molecule after association. We call this as dimerization. Two molecule becomes one molecule. The same acetic acid, if I take it in water, CH3COOH, if I dissolve it in water, then it would dissociate so as to produce acetate ions plus H plus ions. I can also call it as H3O plus ions. So now you can understand, depending on the solvent, the given substance may undergo, this is called as what? Associated. It has undergone association, or we can call it as associated. And here you can tell that the particle has undergone dissociation. Here dissociation takes place. So it is very important to include the Van't Hoff factor. Dissociation. I think this point is clear to everyone. So acetic acid or any other solutes can also be taken. When it is taken in a non-polar solvent like benzene, it undergoes association. Here two molecule becomes one particle. So then we call this as association. This is called as dimerization. This is called as dimerization. This is called as dimerization. And if acetic acid undergoes dissociation, then we call here one particle becomes two particles. So depending upon whether it undergoes association or dissociation, so we can decide the Van't Hoff factor. Okay, let me go for the next case. Let me show you how the dissociation or association takes place. Let me take the example of CH3, C double bond O, OH. This is acetic acid. Let me write another acetic acid molecule. Let me write it as CH3, C double bond O, OH. I am writing two different molecules. This is called as 2 acetic acid molecule is taken. When I take it in benzene, when I take this in benzene, when it is dissolved in benzene C6H6 liquid, this is acting as a solvent. Then there will be association between acetic acid molecules. Let me show it by dotted line. So that dotted line is called as intermolecular hydrogen bonding. This is called as intermolecular hydrogen bonding. Intermolecular hydrogen bonding. This is called as intermolecular hydrogen bonding. It would associate so as to form one particle. So it leads to formation of CH3 COOH 2 times. See, we call this concept as dimerization. Dimerization. What do you mean by dimerization? Two particle associates to form. Two particles becomes one particle, then we call it as dimerization. If three particles becomes one particle, then we call it as trimerization. Trimerization. If four particle becomes one particle, then we should call it as tetramerization. Tetramerization. What do we call it as? Tetramerization. Now let us calculate what is the Van't Hoff factor when acetic acid is dissolved in benzene. Students, now let us see here. You can understand that on the reactant side, I have to write here as CH3 COOH has become one particle twice. Now, what would be the Van't Hoff factor I for this? Now you know that Van't Hoff factor I is nothing but equal to number of particles or number of moles of particles after association is 1 divided by number of moles of particles before association or dissociation is 2. 1 by 2. So now clearly you can tell 1 by 2, if it has undergone 100% association, the value of I becomes to be 0.5. Now suppose say that acetic acid CH3COH completely dissociates in water. Let us say that it completely dissociates, hypothetical. Then this will become CH3CO minus plus H plus. If it gets completely, for taking out the ambiguity, let me write as CH3CONA, then this becomes CH3COO minus plus Na plus. Now tell me what is the Van't Hoff factor, students? Van't Hoff factor I will be equal to number of particles after dissociation is 2 divided by before dissociation is said to be. So this is aqueous. Water is not an electrolyte. After write as aqueous, then this will be equal to 2. Similarly, the value of Van't Hoff factors can be asked for different things if it is undergoing complete association or dissociation. Now, I'll give you some questions based on this. What will be the Van't Hoff factor I? What will be the Van't Hoff factor I? I is equal to question mark, assuming complete dissociation for the following. Complete dissociation for the following. Now let us say that I am giving you certain important things like K2SO4, assume complete dissociation, barium chloride, aluminium sulfate, Al2SO4 thrice, sodium sulfate, or it can be magnesium sulfate, MgSO4. Assuming complete dissociation of these electrolytes in water, you have to calculate the Van't Hoff factor values. Do it, students. I told you what is I. You know that potassium sulfate in aqueous medium completely dissociates to form 2K plus SO4 2 minus aqueous. These are in aqueous medium. Therefore, Ki Vent off factor will be equal to number of particles after dissociating. One particle is 2 plus 1, 3 divided by 1. So what is the Vent off factor, students? 3 if it is completely dissociated. Tell me aqueous solution. This will dissociate to give you what? Ba2 plus aqueous plus 2Cl minus aqueous. Therefore, I will be equal to number of particles after complete dissociation is 1 plus 2, 3. 3 divided by 1, this is equal to 3. Similarly here, an aqueous solution, this will dissociate to give you 2Al3 plus aqueous plus 3SO4 2 minus aqueous. Now tell me, students, what is therefore what is the value of I? I will be equal to 2 plus 3, 5 divided by 2 plus 3 equal to 5 divided by 1. This is equal to 5. That is equal to 5. Now tell me, students, what will be the answer for this? Without writing the equation, I will be equal to 2Na plus SO4 2 minus number of particles produced is 3 divided by 1, that is equal to 3 MgSO4. So I will be equal to Mg2 plus SO4 2 minus. So therefore 2 particles are produced divided by 1, this is equal to 2. So this kind of questions, assuming complete dissociation, what would be the Vent off factor can be asked. You have seen all the electrolytes which undergoes dissociation would have a Vent off factor greater than 1. So therefore, finally to conclude, we can say that if I value is greater than 1, solute undergoes dissociation, solute dissociates, if the value of I is less than 1, then solute associates, and if the value of I is equal to 1, no dissociation of electrolyte, no dissociation of the substance solute, or no association. This is very, very important, students. This can be asked. If the Vent off factor is greater than 1, or if it is less than 1, or if it is equal to 1, what are the conclusions that can be drawn? Okay, now there can be certain problems asked based on percentage of dissociation. So therefore, degree of dissociation, let me give you two important sets of formulas for solving the problems. Degree of dissociation, alpha D, and Vent off factor, So we need to study the relationship between them. Relationship between Vent off factor and degree of dissociation alpha D. I'll give you the relation directly, students. You don't have to derive it, but even deriving that is not a difficult part. It is an easy part. So let us say that we have a solute as AN. Let us say that we have a solute as AN, which will dissociate so as to give you Na particles, just like as in our equilibrium chapter what we have studied. Let me call it as initial. Let us say that we have taken Ni moles of the particles, product should be 0. Let us say initial moles, reacted, or we can write as lost or gained moles. Lost or gained moles, let us write it as minus Ni into alpha d, minus Ni into alpha d. Then gain should be Ni into alpha d into n multiplied by the stoichiometry. Last year you have studied, so C alpha. So here we have written C alpha. If the stoichiometric coefficient is other than 1, then we have to multiply by the respective stoichiometric coefficients. So now remaining moles will be equal to Ni minus Ni alpha d, and here it will be Ni alpha d into n. I think this point is clear to you, students. Initial moles was Ni, this is 0. Lost or gained moles would be minus Ni into alpha d. Alpha is the degree of dissociation. This is Ni into alpha d into n, because you have a stoichiometric coefficient as n here. So here I have to multiply by n. Then remaining will be Ni minus Nf, initial minus final, initial minus final. This is Ni into alpha into d. I think this point is clear to you, students. Okay, remaining is this much. Now, what will be the final number of moles that is remaining? Final number of moles that should be equal to, we have to add all these things, Ni minus Ni alpha d plus Ni alpha d into n. Students, I think you can understand this. N final will be equal to, I can take Ni as common here, then I can take it as 1 minus alpha d plus n into alpha d, implies N final by Ni will be equal to 1 minus alpha d plus n into alpha d. Now tell me, students, what is this called as? Number of particles after dissociation divided by number of moles of particle before dissociation, and this should be called as, this should be equal to the Van 't Hoff factor I. This should be equal to what? Van 't Hoff factor I. So what is Van 't Hoff factor I? That is equal to n final by n initial, that is equal to 1 minus alpha d plus n into alpha d. So if I want to get direct relation between I and alpha, now let me write it here. From this we can write I is equal to, as we have derived, 1 minus alpha d plus n into alpha d. So therefore I, when I bring it this side, becomes minus 1. This is equal to, I can take alpha d as common into, I should write it as, alpha d is taken as common, then I write it as n minus 1. So which implies that alpha d is equal to I minus 1 divided by n minus 1. So an important relation, students. You don't have to remember the derivation. Alpha of dissociation, or that is degree of dissociation, is equal to I minus 1 divided by n minus 1. You should know what is this n. N is the number of particles produced, by dissociation of one particle, This is very, very important relation, students, for solving the problems. Degree of dissociation alpha d is equal to I minus 1 divided by n minus 1. Now we can also write the values of n for the following. Can you tell me what will be the value of Al2SO4 thrice? What is the value of n? N is how much? to use in this formula. N will be equal to 5. If I write BaCl2, upon dissociation it produces 3 particles. If I take NaCl, so it produces 2 particles. If I take K2SO4 potassium sulfate, 2K plus plus SO4 2 minus, it produces 3 particles. By the complete dissociation of one particle, how many particles are produced? That is said to be the value of N in the formula. I think students this is clear. So what is the relationship between degree of dissociation alpha D and Vent of factor I? So that is equal to alpha D equal to I minus 1 divided by N minus 1. And what is N? N is the number of particles produced by the complete dissociation of one particle. Okay students, let us go for relationship between Let's derive another relation. Derivation is not important, only the final conclusion is important. Relationship between degree of association, let me write as alpha A, and Vent of factor I, Let us say that Na is the number of solute particles which will associate so as to form An. Let us write initially we have taken Ni number of moles, this will be 0. Lost or gained, so let me write as Ni into alpha A minus Ni into alpha A. So we shall call this as degree of association. This will be equal to Ni alpha A divided by N, because you know that if N mole are there, it will become by the stoichiometric coefficient. So therefore minus Ni alpha A, this will be plus Ni alpha. What is remaining? It will be Ni minus Ni alpha A. This will be Ni alpha A divided by N. Now can you tell me students, what is the final number of moles? Final number of moles Nf, that will be equal to sum of all the moles, that is Ni minus Ni alpha A plus Ni alpha A by N. Now you can see everywhere you have Ni as common into 1 minus alpha A plus alpha A by N. Alpha A divided by N implies I want to get the Vent of factor I is equal to N final divided by N initial. So that should be equal to final number of moles, we know what is that. So that will be equal to, if I bring it to the denominator, that will be equal to 1 minus alpha A plus alpha A divided by N, where N is nothing but number of particles that is going to associate so as to form one particle. So now I can say what will be the value of I will be equal to, or I can bring this one this side, I minus 1 will be equal to alpha A can be taken as common into 1 by N minus 1 implies I can write this as alpha A is equal to I minus 1 divided by 1 by N minus 1. A very important formula that has to be remembered. Alpha of association is equal to I minus 1 divided by 1 by N minus 1, where N is number of particles associating to form one particle. It is very clear that N is the number of particles that is associating so as to form one particle. So what does N stands for? Number of particles associating so as to form one particle. So now tell me students, for association, if I say dimerization, for dimerization n will be equal to how much? 2 particle will associate. For trimerization, what will be the value of n? N will be equal to 3 particle will associate to form 1 particle. For tetramerization, if it is tetramerization, if I write here tetramerization, what will be the value of n? N will be equal to 4. 4 particles will associate so as to form 1 particle. So this relation is important. Alpha of A is equal to I minus 1 divided by 1 by n minus 1. I think all these points are clear to you, students. So now, based on the Van't Hoff factor including, we have to solve certain problems. So to summarize, I would say, so we will write the formula what we have written at the end of the chapter after discussing the concept of colligative properties. The things that we have discussed is that what is Van't Hoff factor I? I was defined in 3 ways. So I'll write in short, that is said to be normal molar mass divided by abnormal molar mass. Normal molar mass divided by abnormal molar mass. This was one formula. And we have written observed colligative property divided by calculated colligative property. And the formula that we have studied was that number of particles, number of moles of particles, number of moles of particles after association or dissociation divided by number of moles of particles before association or dissociation. Then including this Van't Hoff factor, we have written the formulas like RLVP is equal to P1 naught minus P1 divided by P1 naught is equal to W2 into M1 divided by M2 into W1 into I. Delta TB is equal to KB into M into I. Delta TF is equal to KF into M into I. Pi is equal to CRT into I. Then at the end of the chapter, alpha of dissociation is equal to I minus 1 divided by n minus 1. Alpha of association is equal to I minus 1 divided by 1 by n minus 1. So these are the important formulas that you need to remember for solving the problems. I think all points are clear to you, students. Just note down. Then finally, that we have concluded that if I is less than 1, I is greater than 1, or I is equal to 1, here no association or dissociation, here dissociates, here it dissociates, here the solute undergoes association, These are the important points. Here we have finished the chapter of solutions. We have to start solving the problems based on the last concept that we have discussed. Let us go for the problem, students. Okay, now read the question, students. Let us start solving this. Question number 19, which is given in your study material, it is in page number 92. As I told you earlier that we are going to solve question number 19 at the end of the chapter. So just go for page number 92. Question number 19, page number 92 in your study material, question number 19. You don't have to write the question. Let us write given. What all things are given? Let us start writing given. You have to determine the osmotic pressure of a solution. Pi has to be calculated, which has 50 gram of K2SO4. So they have given what is the mass of K2SO4 that has to be dissolved. 50 grams of K2SO4 has to be dissolved. So let us write W2 is equal to 50 gram. They have given volume of the solution is said to be 2 liter, and they are saying temperature is equal to 25 degrees Celsius. That should be equal to 298.15 Kelvin. You can take 298 also. Assuming complete ionization means K2SO4 dissociates completely so as to form 2K plus SO4 2 minus. So now students, we know the formula for pi. So since it is an electrolyte, since it is dissociating, so can you tell me what is the Van 't Hoff factor I for this? I will be equal to number of particles after dissociation divided by, what is the number of particles after dissociation? 3 divided by 1. So I factor is known to be 3 since it is complete dissociation. R value is also given as 0.082 liters atm per Kelvin per mole. These many values are given. Now you need to calculate the osmotic pressure. Pi will be equal to W2 into RT divided by M2 into V into Van 't Hoff factor I. So this will be equal to W2 is 50 multiplied by R value is known, it is given 0.082 multiplied by temperature is known as 298.15 divided by M2 is known. What is the value of M2? Molar mass of potassium sulfate has to be calculated. So K2SO4. So we can write the molar mass as 39 into 2 plus sulfur is 32 plus 16 into 4 is 64. So if you add all these things, the molar mass comes out to be 174 gram per mole. So M2 of the solute is known as 174 into volume of the solution in liter, that is 2 liter, multiplied by the Van 't Hoff factor. So you can calculate pi value. Take the calculator, solve and tell me students what is the answer. Pi will be in terms of atm. Because the unit of this is 0.082 atm liter per Kelvin per mole. Take the calculator, solve and tell me students what is the answer. Answer comes out as 10.538 atm. 10.538 atm. Okay. Did you note it down, students? Shall we go for the next problem? Problem number 22 from your study material. It is given in page number 93. It is given in page number 93. You don't have to write the solutions, just go for page number 93 in your study material and start solving the problem. Molar depression constant for benzene is 5.0 Kelvin kg per mole. So what they have given is this 5.0 Kelvin kg per mole is depression constant is Kf. Kf is given. So Kf is equal to 5.0 Kelvin kg per mole. A solution prepared by dissolving 2.5 gram of benzoic acid. Solution is prepared by dissolving 2.5 gram. So W2 is equal to 2.5 grams. That is solute. In benzoic acid, to benzoic acid in 35 grams of benzene. So W1 is equal to 35 grams, which will freeze at, they have given TF at 277.1 Kelvin. So 271 Kelvin, 277.1 Kelvin. So 35 grams already we have noted. Now we need to calculate Van't Hoff factor I is equal to question mark, and they have given what is TF naught. TF naught is equal to 278.6 Kelvin. Students, what we need to calculate is I. So I have given you what all data are given. Now can you solve and tell me, students, what will be the value of I? So now you know that delta TF is equal to Kf into W2 into 1000 divided by M2 into W1 multiplied by the Van't Hoff factor I. We need to calculate I. We need to calculate the value of I. So delta TF value is to be calculated. So you can calculate it here. Delta TF is equal to TF naught minus TF, that will be equal to 278.6 minus 277.1. So you can calculate what is the value of delta TF, that will be equal to 1.5 Kelvin. That will be equal to 1.5 Kelvin. Now substituting all these values, you can calculate what is the value of I. So I will be equal to delta TF into M2 into W1 divided by KF into W2 into 1000. So now we can substitute all these values. Delta TF is 1.5 multiplied by molar mass M2 of that benzoic acid has to be calculated. So you know what is the formula of benzoic acid, C6H5COOH. So you can calculate the molar mass, 12 multiplied by 7 plus 6 plus 32. So that comes out to be 122 gram per mole. What is the molar mass? 122 gram per mole. So you can substitute here. It is 122 multiplied by W1 value is known. W1 is coming out as 35. You can see, divided by KF value is known. So KF is 5 multiplied by W2 is known. It is 2.5 multiplied by 1000. You can calculate what is the value of I. Implies I will be equal to, I is equal to 0.512. I will be equal to 0.512. I will be equal to 0.512. So first question is over. You have to calculate the percentage of association. For association, you know that alpha A will be equal to I minus 1 divided by 1 by n minus 1. This will be equal to, I value is known as 0.512 minus 1 divided by 1 divided by, you know, number of particles for association required is 2, 1 by 2 minus 1. So implies alpha of association is equal to, alpha of association will be equal to, calculate and tell me, students, what is the answer? 0.976. So therefore percentage of alpha association will be equal to alpha A multiplied by 100. So that will be equal to 0.976 multiplied by 100, that is equal to 97.6%. That is equal to 97.6%. So what is the percentage of alpha? That will be equal to 97.6. What is the Van't Hoff factor I? That is equal to 0.512. So answer for the given question is I is equal to 0.512 and alpha of association will be equal to 0.976. Percentage of alpha A will be equal to 97.6. So this is the answer for the given question. I think this is clear, students. Shall we go for the next question? Look into the next question. Question number 23 given in your material. It is in page number 93. It is in page number 93. Assuming complete dissociation, assuming 85% ionization. What is the meaning of 85% ionization? 85% ionization means alpha of A is equal to 85 by 100. 85 by 100, that is equal to 0.85. What would be the depression in the freezing point? They are asking what would be the depression in the freezing point. Delta TF is equal to question mark. For molality is given as 0.7 molal solution of barium chloride. Barium chloride dissociates to give you Ba2 plus 2Cl minus. This you need to remember. Now what we have to calculate? So you have to calculate depression in freezing point. What is the formula, students, to calculate the depression in freezing point for an electrolytes? Delta TF is equal to Kf into W2 into 1000 divided by M2 into W1, M2 into W1 into I. In short, this can be written as Kf into M into I. Molality need not be expanded because molality is given directly. Okay, now let us start substituting. So delta TF value has to be calculated. So Kf value is given here as 1.86. 1.86 multiplied by molality value is given as 0.7 multiplied by Van't Hoff factor I value has to be known. So they have not given the Van't Hoff factor value I. Now we can determine the value of I using this equation. We can determine the value of I using alpha of dissociation is equal to, sorry, this is D, alpha of D. Alpha of dissociation is equal to I minus 1 divided by N minus 1. Already we have derived it. Alpha D is equal to I minus 1 divided by N minus 1. What is the value of N from here? You can tell one particle is going to become two particle. So therefore alpha is known as 0.85, that is equal to I has to be calculated minus 1 divided by 2 minus 1, implies what will be the value of I? 0.85 into 1 into 1. When I bring it to the other side, it becomes plus 1. This is equal to I, implies I will be equal to number of particles, sorry, this will be equal to 3. 2 plus 1, 3. So I have to multiply by 2. So plus 1, this is equal to I, implies 0.85 into 2, this will be equal to 2.7 plus 1 is equal to I, implies this is equal to 0.85 into 2 is 1.7, 1.7 plus 1, this is equal to 2.7. So this is equal to I. So you got the value of I value is said to be 2.7. So if you now find out delta TF will be equal to 1.86 into 0.7 into 2.7. So when you calculate, it becomes to be 3.5154 Kelvin or degree Celsius, difference would remain the same. Next, is it clear, students? So question number 23 is solved. Students, before coming to the next class, you need to work out certain questions from your NCERT. I would just mention the question numbers that you have to solve and which you have to solve and come. So hereby the chapter solution is over. Solution chapter that we have completed here. So you have to work out example. This is NCERT example. You have to refer NCERT example 2.8, 2.6, 2.9, 2.9, 2.10. These are all familiar examples that I have solved in the class, and you should also work out the question 2.12, 2.12 and 2.13. These are the NCERT examples that you need to work out and come. NCERT in-text question, NCERT in-text question, you need to solve 2.8. This is in-text and this is example. So refer your NCERT book, work out all those problems, and the problems which are given in your study material, that is in page number 95, material questions, work out on all those things. Answers are given, material questions. Which is there in the previous examination questions in page number 95 and 96. 1, 2, 3, 4, 5, 6, 7 and 8. Work out all these questions. So in my next class I will be going for level 1 questions, and we'll go into the next chapter. Level 1 questions. Level 1 questions you just try. We call it as CET or level 1 questions. So you just work out on these questions and be ready. In my next class I will be going with the CET questions, and I would work out certain problems like 2.12 and 2.13. So you can work out on these things. So we can wind up our class today, so that I have finished the chapter of solutions. Definitely in the chapter of solutions you can score 7 marks out of 70 in the annual examination. So you got 10% of your annual examination marks from this chapter, 7 out of 70. Please work out on all these questions, and next class I'll go for CET level 1 questions. Thank you.